Algebra 2. This is Unit 8, Lesson 4, and today we're going to talk about fractional exponents and simplifying exponents. So we talked about fractional exponents already, but we're going to work some more with that. So when you see a fraction in the exponent, you're going to think of a radical. So if you have a fraction as the exponent, you always want to think a radical. And remember, so if I have b to the 1 over n, that denominator is my root. So this is the nth root of b. The numerator is my exponent. This was a 1 though, so I don't need to do anything. So look more at the second one, b to the m over n. Remember, the n is the root and the m is your exponent. That exponent can be under the square root, or it can just be written like this. So this one I'll write like this. So the whole thing could be to the m, or I could have it underneath the radical with that b. Either way is exactly the same. All right, so let's look at some of these. The 5 is outside, so the 5 is hanging outside in front. I want to rewrite each of these in the form ax to the b. So the 5 is out front, the x is here. If there is no number, there's a 2, and there's no number here, it's a 1, so it's just 5x to the 1/2. B, second one. So there is a 1 up here, so I'm going to leave this as 1/4, all right? And then the 5 is the denominator of the fraction, and the 1 is the numerator, so it's going to be b to the 1/5. All right? 7's hanging out in front, and this is really just going to be x to the, this x is underneath, so let me leave it underneath for just a second. So the 3 is the root and the 1 is the exponent, so it's x to the 1/3, okay? But I want to write it in this form right here, so I can't leave it as a fraction. I'm going to take this 1/3 and I'm going to bring it up top, and that's going to result in it being 7x to the negative 1/3. And then this next one, I have 5. Let's change this radical first. So the 3 is hanging out in front. X, this is a 1, so it's going to be 1/10. All right, but again, I want to bring this up to the top. So it's going to be 5/3 x to the negative 1/10. All right, so that's just, again, just reviewing stuff that you should already be comfortable doing. In exercise 2, I just want to rewrite each of the following root combinations as a rational exponent in simplest form. So remember, this is a 2 if there's no number, so it's x to the 7/2. All right, the root is the denominator and the exponent is your numerator. So x to the 6/4. Now this you can actually reduce, and you could write it as x to the 3/2. So put in those 2's if it's just a square root, all right, just so you can easily switch it back. So x to the 6/2, and I can reduce that fraction x to the 3rd, because 6 divided by 2 is 3. All right, so if the number's not there for the square root, put it in so you can easily write your fraction. Here I have the number, it's a cubed root, so x, and it's the 10/3. The root is your denominator and the exponent is your numerator. Perfect. All right. Next one wants us to try and evaluate f of 4 without using a calculator. Of course, using a calculator would be pretty simple. So I'm going to do f of 4, 10 times 4 to the 3/2 minus 24 times 4 to the negative 1. All right, well, let's see how we're going to do that. Let's make this 4 a radical, because I can do square roots in my head. All right, so this is going to be 10, and it's going to be the square root of 4 to the 3rd power. All right, so I took the fraction and I wrote it back as a radical. And then 24, 4 to the negative 1, I just put it as 4 to the positive 1. Now the square root of 4 is 2, so basically I have 10 times 2 to the 3rd minus 6, because 24 over 4 is 6. 2 to the third is 2 times 2 times 2 is 8. So 10 times 8 is 80, and 80 minus 6 is 74. All right, so you took something that was pretty complicated and we made it into a equivalent form that I could actually figure out without a calculator. And the last one on this page wants to know which is not equivalent to x to the negative 7/3. Let's start off by making it positive, so 1 over x to the positive 7/3. Now let's write it as a root, so the 3 is the root, and the 7 is the exponent, and then let's look to see if I see anything that looks like that, and it looks like it is choice 2. Oops, I messed this up, didn't I? Oh, because I'm looking for something that's not. I forgot. All right, I was looking at my paper for a second, and I'm thinking, why did I circle that? So you're looking for something that's not equivalent. They have the 7 and the 3 in the wrong spot. All right, so let's talk about simplifying exponents on the next page, and that's going to be it for today. So we have to go over our perfect squares. Our perfect squares are square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root of 49, square root of 64, square root of 81, and square root of 100. How do I get these? I just did 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. All right, now, also I can have letters under there. So if I have the square root of x squared, that equals x. The square root of x to the 4th equals x squared. The square root of x to the 6th equals x to the 3rd. So as long as it's an even number, then the square root of that is just half of that exponent. And my perfect cubes, square root of 1 is a perfect cube because 1 times 1 is 1 times 1 times 1 is 1. And the cubed root of 8 is 2. The cubed root of 27 is 3 because 3 times 3 times 3 is 27. The cubed root of 64 is 4. So you should also be familiar with our perfect cubes. Because notice I call them perfect squares and perfect cubes because the answer is actually an integer. You're not going to get a decimal. It's not an irrational number. All right? And then I could also do x's, but the x's would have to be a multiple of 3 in order to work. So the cubed root of x to the 6th, remember, let's put that back as a fraction, is really x to the 6 over 3, which is x squared. All right, and if I had the cubed root of x to the 9th, that's really x over 9 over 3, which equals x to the 3rd. So as long as it's a multiple of 3, then that exponent, then you can also do cube roots. All right, so simplify. Change the expression into a product of a perfect square and another factor, and then simplify that perfect square. First ones are just really simple, though. Square root of 169 is 13. B, I have the cubed root of negative 27. Well, that's going to be negative 3, because negative 3 times negative 3 times negative 3 is negative 27. And then if I have the square root of a squared b to the 6th, remember you're just taking half of that exponent. So square root of a squared is a, and the square root of b to the 6th is b to the 3rd. All right, let's do some with some numbers that are a little bit more complicated. To change these, I need a perfect square and then another factor, and then I simplify the perfect square. So square root of 175. The perfect square I'm going to use is 25. I want the largest perfect square that goes in. 25 times 7 is 175. I write that perfect square first because that's going to get simplified. The square root of 25 is 5. And my answer is 5 radical 7. Now when I have a mix of numbers and letters, just look at the number first. So I'm looking at 360. I'm going to simplify it. I'm going to break it down to radical 36 and radical 10. Radical 36 is the perfect square. I always want the biggest perfect square I can get. That simplifies to 6. All right? The 10 is going to stay radical 10. Now, r is r to the 1. That's going to stay under the radical also. S squared is an even number, so that s can actually come out of the radical. The r is going to stay under the radical because it's a single exponent, it's x to the 1. It's an odd number. S squared, the square root of s squared is s. That comes out. And I should have left myself some more room here. So let me move this 6s over a little bit because I got to deal with my t's. Now here's what's going to happen with the t's. The t's are going to break down to t squared and t. Well, the t squared is going to come out of the radical and be t, but the odd one that's left over is staying under the radical. All right, so this is my answer right here. So if you have an odd number, you can pull out the even part of it, and then the single odd number is going to stay underneath that radical. We'll look at some more like that. Let's break down 18. 9 times 2 is 18. You're always thinking, what's divisible? What perfect square goes into that? Well, square root of 9 is 3, and square root of 2 stays under the radical. Now let's look at my exponents. A to the 6, well, that's an even number, so that can come out, a to the 3rd. B to the 10th, again, that's an even number, so that can come out. And again, I didn't leave myself enough room. All right, so b to the 5th, we're always doing half, and then the radical 2. So I do the numbers, and then I'm going to deal with those letters. All right, now the negative in front on that next one is just saying my answer is going to be negative. So the square root of 81 is a perfect square. Perfect, so that's negative 9. M to the 64 is an even number. Perfect, so it's just m to the 32nd. All right, square root of 40, I got to break it down. Well, 4 times 10 is 40. 4 is the perfect square. That gets simplified to 2. The 10 will stay under the radical. X to the 8th is an even number, so I'm just going to pull out. It's going to get simplified to x to the 4th. 25 is a perfect square. It equals 5. Now x to the 7th is going to break down to the biggest even number, x to the 6th, and then the odd one that's left over. All right? The even one is going to come out with the 5 and no longer be a radical, and the odd one that's left over stays under the radical sign. So that's how that's working. Cube roots are definitely a little bit more complicated to do. So I got the cubed root of 24. So I'm going to break that down to the cubed root of 8, which is a perfect cube, and the cubed root of 3, because 8 times 3 is 24. And the n's I'm going to break down to the cubed root of n to the 3rd, because remember I want multiples of 3, and then the cubed root of n, the one left over. So the cubed root of 8 is a perfect square. It equals 2. The cubed root of n to the 3rd is a perfect cube. It equals n. And then the things that are left over will stay in there, the 3 and the n. So these I could simplify, and they became that. And the other ones I couldn't simplify. They stayed under the radical. So that's how that works. All right. And let's look at this next one, k, 2x. So that's going to hang out in front. Let's worry about the 12. 12 breaks down to 4 and 3. Let's break down the x to the 5th. So that breaks down to x to the 4th and x, because I want an even number. So anything that can be simplified, which is a perfect square, are these guys. Those are coming out. So 2x, square root of 4 is 2, so I'm going to have to multiply that by 2. And the square root of x to the 4th is x squared. Those are all coming out. I'm going to highlight them so you can see how those came out. The ones that are left will stay under the radical. And then I'm just going to simplify everything in front of the radical. 2 times 2 is 4, and when I'm multiplying, I add those exponents. So there's my answer. So these definitely, you're going to have to think on them. They're not super simple. Cubed roots, I'm going to break down the 16 to the cubed root of 8 and the cubed root of 2, because 8 times 2 is 16. And the cubed root of 8 is a perfect square. All right, so we're just practicing these, and we will practice them as well tomorrow, but at least you will have done some here. Cubed root of 250. Oh, that's a tough one. So 125 is actually a cubed root. Whoops, let me write 1. Cubed root of 125, because 5 times 5 times 5 is 125. And then I have 2. 125 times 2 is 250. The cubed root of 125 is 5, and the cubed root of 2 will stay a cubed root of 2. Cubed root of 216. That's actually a perfect cube. 6 times 6 times 6 is 216. So that's coming out. This part's coming out. It's no longer a cubed root. And n to the 8th, I have to break down to a, remember I want it to be an exponent that is divisible by 3. So the highest number I can pull out is 6, and then I will have n squared. So this is going to get simplified. The cubed root of n to the 6th gets simplified, and it is just n squared. And then the cubed root of n squared will stay n squared. So it's 6n squared, cubed root of n squared. Oh, and the fourth root. All right. The fourth root of 16, that's actually a perfect number. 2 times 2 times 2 times 2 is 16. And 8 is also divisible by 4, so it's just going to be 2x squared. All right, so we'll practice all those again tomorrow. You're definitely going to need some practice on these. They're not hard, just practice.